Assalamu alaikum students. In this lecture we will discuss vapor absorption refrigeration cycle through temperature entropy diagram. This refrigeration cycle is applied on chillers which operate on heating source such as steam, hot water or exhaust gas. Let's understand each component of these chillers step by step through which refrigerant passes to complete its cycle. If I start from evaporator, so here evaporator is a shell and tube type heat exchanger. In the shell of evaporator, showering of refrigerant is performed, while in the tubes of evaporator, chilled water is circulated. As a result of heat exchange, refrigerant absorbs the heat of chilled water, due to which it changes its phase from saturated liquid vapor mixture state to superheated vapor state at the outlet. During this heat absorption process, the temperature of refrigerant remains constant until it reaches the state of saturated vapor state. After that, the temperature starts increasing until the outlet of evaporator. Absorber is separated from the evaporator using baffles. It is a shell and tube type heat exchanger. In the shell of absorber, showering of strong solution is performed, while in the tubes, cooling water is circulated. In the shell of absorber, strong solution absorbs the incoming vapors of refrigerant, due to which its concentration starts decreasing, and at the outlet it becomes a weak solution. In addition to that, refrigerant rejects its heat to cooling water as a result of heat exchange, due to which refrigerant changes its phase from superheated vapor state to subcooled liquid state. So, as you can see in this diagram, that at the inlet of absorber, refrigerant is in superheated vapor state, while we have a strong solution having concentration of 64%. Now, if we take a look at the outlet we have weak solution having concentration of 58% of absorbent, and our refrigerant is in subcooled liquid state. Before entering the generator, this weak solution is required to be preheated. For this purpose, we pass this weak solution through a counterflow type heat exchanger. In this heat exchanger, the strong solution moving from generator towards the absorber acts as a hot fluid, while the weak solution moving from absorber towards the generator acts as cold fluid. As a result of heat exchange, the temperature of weak solution is increased before entering the generator. In chillers, generator is also a shell and tube type heat exchanger. In the tubes of generator, heating source passes, which may be steam, hot water or exhaust gas, while in the shell of generator, weak solution enters. As a result of heat exchange, weak solution absorbs the heat of heating source, due to which it gets converted into a strong solution. In addition to that, refrigerant gets separated from the solution due to its lower boiling point, and it changes its phase from subcooled liquid state to superheated vapor state at the outlet. So, if we take a look at this diagram, at the inlet of generator we have weak solution and our refrigerant is in subcooled liquid state, while at the outlet of generator we have a strong solution and our refrigerant is in superheated vapor state. In condenser, cooling water is circulated inside the tubes while the refrigerant enters the shell. As a result of heat exchange, refrigerant rejects its heat to cooling water, due to which it changes its phase from superheated vapor state to saturated liquid state. Initially, at the inlet of condenser, the temperature of refrigerant decreases significantly. It keeps on decreasing until it reaches the state of saturated vapor state. After achieving saturated vapor state, the temperature of refrigerant remains constant inside the condenser. Expansion tube here acts as a restriction which maintains the pressure difference between condenser and evaporator. When refrigerant travels from condenser towards the evaporator, its temperature decreases. Along with decrease in temperature, the boiling point of refrigerant also decreases, due to which we see a phase change in the refrigerant. At the inlet of expansion tube, the refrigerant is in saturated liquid state, while due to decrease in boiling point, we see that at the outlet of expansion tube, we have our refrigerant in saturated liquid vapor mixture state. Now if I summarize this whole refrigeration cycle, I observe that whenever refrigerant is absorbing the heat, its entropy is increasing, as you can see this phenomena in case of evaporator, generator and cold fluid of heat exchanger. In the same way, wherever refrigerant is rejecting its heat to its surrounding, its entropy is decreasing. As you can see this phenomena in absorber, condenser and hot fluid of heat exchanger. For expansion tube, as the phase changes from liquid to vapor, so we observe a slight increase in entropy of refrigerant. Now if I talk about temperature, under the saturated area, there is no change in temperature in all the components of chiller. But if I talk about the subcooled region or superheated region, we observe that whenever heat absorption takes place, temperature is increasing. As you can see that in case of cold fluid of heat exchanger, heat is absorbed and temperature is increased. Same is the case near the outlet of evaporator for refrigerant. And now if I talk about heat rejection, so in these regions, subcooled and superheated vapor region, we observe that whenever heat rejection takes place, temperature decreases. As you can witness this at the inlet of condenser and for hot fluid of heat exchanger. As in both these places, heat rejection is taking place and these places are out of saturated region. So we observe that decrease in temperature is taking place. I hope this concept about refrigeration cycle is quite clear now. Now if I talk about absorbent and refrigerant pairs, some of the famous absorbent and refrigerant pairs are lithium bromide and water and ammonia. In case of lithium bromide and water, lithium bromide is the absorbent and water is used as refrigerant, while in case of water and ammonia, ammonia is utilized as refrigerant while water is used as absorbent. Coefficient of performance is a parameter which is used to show the performance of any equipment. So for the case of vapor absorption refrigeration cycle, we can calculate the coefficient of performance by taking thermal kilowatt of evaporator as our output and thermal kilowatt of generator as our input. As in the evaporator, we have our chilled water, which is the main outcome of this chiller, is the product of this chiller, and in generator we have our heating source. So we take thermal kilowatt of generator in our input as our input. This is the expression through which you can calculate your COP just by using temperature, just by knowing the temperature at different components of chiller. I hope this concept about vapor absorption refrigeration cycle is quite clear now. Do let me know if you have any question about this concept. I would love to answer your queries. Thanks for watching.